floodplain through which a large river flows. So if we go to the first slide, this is a picture that shows the outline of the metropolitan area of Seoul. That's the only thing I'm going to be talking about tonight, except when I go on to earthquakes. So we can see right at the back around the northern rim, we've got the high mountains. They're not shown particularly well in the Seoul area because they're just outside of it. We've got low hills coming down on the east and the low hills, not quite shown there, coming down on the west. And we have this low hill in the front, which is Mount Nam, and then we have the Han River in the front. So actually, the setting of Seoul meets the topographic requirements for this geometric harmony, which of course is illustrated in this early picture down here, fanciful picture, showing you the low hills, the mountains at the back and the river in the front. So what we'll be concentrating on tonight, what we're concentrating on tonight are the geological aspects of the rocks inside that metropolitan area. And here they are. This is a simplified geological map of the Seoul metropolitan area, and you can see that there are three main rock types. So in fact, there are two main rock types, and the white stuff in between, which is essentially down the river valleys, is river sediment. So that is the veneer that's covering what we call the basement rocks. And the two basement rocks, and I have to introduce you to the terms. One is gneiss, this is the purple stuff, and the other one is granite. And the white stuff is river sediment, and I've also plotted on there these lines, these black lines, which will be, I'll talk about the importance of those later on. These are in fact earthquake fault lines. So the geology then consists of two main rocks, and just as a hands-on experience, I'll hand them around and you can have a look, and as I explain them I'm sure you'll understand what I'm talking about in terms of their textures and mineralogy after having looked at them. Well, let's start off with this gneiss or gneiss. It's a metamorphic rock. That means it's a rock that's been changed, the form of which has been changed. And if you look at the textures or the macroscopic appearance of this rock here, you can see all these rocks sitting outside of the garden as you come into the Somerset House. These are, well, this provides evidence for effectively squashing and flattening and stretching and folding, which is what these rocks have been through. A fairly tortuous process deep within the Earth's crust, so they've got this very nicely banded appearance to them. There's the 101 coin in there for scale. In contrast to those kind of rocks, which are the purple stuff, there are these ones, which are granite. There's the other rock coming around. These are quite coarse-grained. They don't have the layered structure at all, so they're very easy to recognize. We've got two filled representations of the granite here and a cut polished slab, so you can easily see the minerals in it. I won't go into the details of what the minerals are, but when you look outside the window here and look around Seoul and you look at all the mountains, what you are looking at effectively are granite mountains, and here's one that I'll talk about a little later on in Subong. Many of these granites are bald. I mean, you can see part of them are covered with vegetation, but a lot of them are just bare rock faces. And this is characteristic of these granites, and it's related to a particular type of erosion and a structure of the granites which makes them like this. It's quite unusual. Anyway, unlike the metamorphic rock, which was some previous rock that got squeezed and squashed and folded, the granite, in fact, crystallized from a molten liquid, probably from a liquid that may have been up to about 800 and 900 degrees and then slowly cooled. It's called a magma. It never reached the surface of the Earth, so it wasn't erupted from a volcano, but it crystallized very slowly beneath the surface of the Earth, and hence its coarse grain size. So the two important rocks then are gneiss and granite. In fact, when you look at the whole of the Korean peninsula, at least southern Korea here, South Korea, 60% of the landmass is covered by granite. It's probably the most common rock in South Korea. And you can see Seoul up there, sort of on the edge of one of these large granite masses. But you can imagine, in fact we know, that although they're separated, these outcrops of granite, they are in fact pretty well continuous underneath. So most of Korea then is covered by granite, and as I said, it covers 60% of the landmass. The other, I guess, geological material which makes up Seoul is this sediment, this river sediment, mainly deposited by the Han River. And here's a map that shows the floodplain, or the areas that are prone to flooding with respect to the Han River. This is the yellow area. And this is where the veneer of gravels, mud and sand deposited by the river is thickest. It ranges up to about 20 metres and gets down to relatively 1 or 2 metres, and it extends up most of the river valleys that you can see here. But the main source of this covering sediment is deposited by the Han River, mainly when it's in flood. Not so much now because there are stop banks preventing the flooding. And here is a picture showing the Han River in flood. It's pretty full there. And in the late 60s and 70s, there were large dredges in the Han River that were scraping out the gravel that was used to make concrete aggregate and roading aggregate. And from those big dredges in the middle of the river, all these little boats went out, got filled up with gravel, and took them back to the riverbank, where they were then crushed and sized and sieved and so forth, and then used in the building program for the miracle, I guess, that was solved. So you can see the localities there. And if there wasn't the stop bank situation, then probably in times of flood, most of that area would be covered and inundated with silt, at least. Now, the one other thing that has been deposited in Seoul, and I believe there was a light coating of dust, Asian dust this morning, is this yellow dust that comes over from China. And on the top right corner there, you can see a dust cloud clearly coming over the Yellow Sea. And this dust falls all over Korea. And if one takes a look under the high magnification, in this case it's a scanning electron microscope, and here you can see the scale there, 0.1 millimeters. We're looking at these kind of particles that are in the dust. There are two kinds of particles that immediately catch your eye. There's the broken up pieces, which are natural mineral fragments. And then there are these circular balls, spherical things, which in the lower part there is a large one shown, and these are anthropogenic. They are coming out of the smokestacks, if you like, of coal-burning electric stations, electricity producing plants in eastern China. They're basically soot. They're essentially iron oxide, but there's a lot of other nasty things in there, like cadmium, arsenic, lead, and these things are simply being picked up in these dust clouds, and they are, of course, falling all over Seoul, so they can be really regarded as a pollutant. There's nothing much you can do about that unless you close down the coal-burning electric power stations in China. And the map shows you trajectories working backwards from the 4 dust storms, showing the locality for where the dust is originally picked up, obviously Siberia, Mongolia, and in northern China. So it's picking up this dust material from the desert dry areas, carrying it up to very high altitudes, and then sweeping it across and depositing it on Seoul and, of course, in the Yellow River. And in doing so, of course, it's picking up and mixing with this soot, this polluted material, which is also coming over. So that dust, of course, doesn't leave a geological signature. It's too small in terms of the amount that's been deposited. I guess if you went to one lake somewhere and put a core down, you might pick up the yearly dust falls on